Hey, thanks for joining me. I'm Zach from MotoCrane, and today we're talking about firmware, more specifically the V1.1 firmware update for Titan, which is our biggest firmware update so far. We've added a lot of new features and functionality that I'm excited to share with you, so let's get into it. So the first big feature that we've added for Titan is, of course, follow mode. Very popular request. If you're coming from the DJI ecosystem, they call it smooth track. If you're coming from FreeFly, they call it majestic mode. We call it follow mode, which really just means that the gimbal follows the movement of what it's attached to, whether that is pan or tilt. So to find follow mode on your Titan controller, you're gonna go to the control menu. It's gonna be in the top right. And then now you have this new follow mode button on the bottom of that window. So now when you go into the follow mode menu, you of course have some settings that you can change to make sure that follow mode is doing exactly what you want. In the tracking vehicle situation, you're probably gonna only want follow mode turned on for pan. This is of course, the vehicle is doing most of its movement around the yaw or the pan axis. You can change the deadband of follow mode, which means that you're gonna allow a little bit of wiggle room before follow mode starts to actually take effect. And then also expo, which means that as you have a higher expo, it means that as the target angle gets away from where it's supposed to be, it's gonna apply a stronger correction. You can of course adjust the strength of follow mode, how smooth it starts and stops into that angle, and then window, which basically serves as like a maximum limiter for how far the gimbal is gonna deflect away from the target angle before it applies 100% of the motor power to get it back to where it needs to be. Next up, for new features and updates, we've completely overhauled how Titan is doing limits. If you've never used Titan before, we distinguish limits into two categories: collision and steering limits. Collision limits are encoder-based, meaning that they are based on the joint angle or the angle that's read by the encoders at each joint. This is typically where people are going to be setting their limits, but we also have limits that are applied to the IMU angle, and we call those steering limits. So to configure limits how you want, we're gonna go to System, Configure Limits. In this case, we're gonna configure some collision limits. These are gonna be based on the joint angle or the encoder angle of each of the axes. These are also called end stops. So currently I have my controls mapped to my wheels here. So if I want, say, my left point or my left end stop to be there, within my new tuning interface, I can just say set limit here. It's going to confirm that my limit is set to that degree. Now, if I want to go and set an end stop here to the right, I can set limit here. Now, while I'm in this confirmation screen, if I change the limit, it's going to give me a live output of where the angle is set to. So I can see that readout from the encoder. So let's say I want it there at 39 degrees. Now I have my limits set. I want to make sure that my limit for that axis is on and also that my master limits are on as well. And now I should have a nice end stop there. So I'm going to continue to wrap this wheel around and it's not going to go past my limits. Another cool feature that we've added to the limits setting experience is the ability to actually configure the limits from the gimbal itself. So to do that, I'm going to first turn off my motors and then go to the gimbal. I'm going to flip it around here so you can actually see the spine screen. And I'm going to go to my home button and I have a limits button right here. I'm going to select limits. And if I wanted to configure an upward limit for my tilt axis, I can just hit that. And now I actually have a live readout of where that limit is going to be. So like, let's say I wanted to set a limit right there. I can say confirm, and now I'm going to set a downward limit as well. And I'm going to confirm that. And now I have limits set using the gimbal itself, and that will automatically update and propagate over to the controller as well. So now I can also see here that on the controller that a tilt limit was set, that they are on. So a very intuitive way to configure limits, both from the Titan controller or from the operator station as you're operating. You can also do it physically on the gimbal as well. Another parameter that we've added is called brake distance. And brake distance is essentially a deceleration period where the gimbal is going to go from its current velocity or its current speed and start to slow down to prevent overshoot of the limit. So if I bring brake distance up much higher, say let's go to like a value of 200, as I'm approaching my limit, it's going to be softening as I get into that limit. So I'm going to continue my velocity here and just let brake distance ease me in to that limit. And so the higher the brake distance, the more of a deceleration period it's going to use to ease me in and land right on that limit without any kind of overshoot. And then of course you can navigate to steering limits as well. And so steering limits are only available on the tilt and roll axes, since these are your attitude axes. But if you wanted to set a stabilized limit, that is again going to be reading the IMU angle, you can also do that as well in the same way that you did for collision limits. So the next update we're going to talk about is probably the most important as far as stabilized heads go. And this is our new Gen 3 sensor fusion, as well as our updated tuning interface, which is a very important part of Titan as a stabilized head. This is essentially the stabilization algorithm that we use to keep the camera and lens totally stable during all of the rigors of dynamic camera movement. So let's take a look at the tuning menu and see what's changed. Now, if you're looking at this as an existing Titan user, it's going to be pretty familiar, but again, it's going to look a little bit more simplified. We still have the ability to select your operating mode between studio and dynamic. GPS assist is available to turn on or off, and then also gyro stabilization on or off as well. You'll see that now there's going to be one primary parameter that you're going to use during the tuning experience, and that's going to be stiffness, which you can see on the far left-hand side next to the gyro rate bar that we've added to visualize any kind of movement on the axis. If you're trying to troubleshoot where a certain shake is coming from, you can use the gyro rate bars to see that in real time. Now, beyond the stiffness parameter, which again is going to be your primary parameter that you're changing during tuning from a preset and optimizing it to basically be the best it can, we also have control and strength. And control is essentially your high frequency response, and strength is your low frequency response. Easy way to think about it is if you are seeing some high frequency shake, you can increase control. If you're seeing some low frequency movement, you can increase strength. So pretty simple to decide which one of those you need to adjust based on what you're seeing come through the lens. And of course, we've updated the presets for small, medium, and large to go along with the new tuning interface. The next big update that we've made in the V1.1 firmware update is to fizz, or the focus, iris, and zoom control capabilities of Titan. We've essentially revamped the whole motor control system to achieve much smoother performance at dramatically lower speeds. We've also added some new compatibility with different variants of third-party motors like the Hedin M21 and M26, specifically the 256 encoder variants, as well as the 512 encoder variants. So just more motors from third-party manufacturers. So this is going to largely look the same until we get into selecting our motor model. And you can see there's just some more variants here for those Hedin motors for you to select. Functionality and how you use fizz is the exact same as before, but again, you're going to see dramatically smoother performance, especially at lower speeds with Titan's onboard fizz. Next up for V.1 is configurable wireless settings. So in order to see this in action, we're going to go to System on the controller and then go to Wireless Settings. And you can see now there is a menu for us to configure the wireless radios on Titan for however we want. Because I have motors on, I'm not actually able to make any changes to my wireless radio settings. If I try to select that, it's going to tell me invalid action, motors are on. And we'll talk a little bit more about the reactive UI later. So in order for me to make changes here, I'm going to turn my motors off. I automatically get these two options. The first one is going to be auto scan. Now, auto scan is a new function that allows the controller receive antenna to basically sniff the 2.4 gigahertz wideband and find the least congested channels to transmit and receive on. So let's see how this works. I'm gonna hit auto scan, and it's given me channel 16 and channel 23 as transmit and receive. While they are yellow right now, it means that those changes are pending, but they haven't been applied. I can of course just hit apply there, and then those changes are applied to the radios. Now, the controller believes that these are the least congested for us to be transmitting and receiving on for the best wireless performance. I can of course just manually dial what channel I want to be transmitting and receiving on as well. So if I want to make sure that I'm on a specific channel, I can just manually select that. I'll go to 13 here and then apply that and make sure that those get propagated to both the gimbal and the controller. The last feature of wireless settings is the ability to do a factory pairing or a bind of two radios. And all you need to do is to install a COM cable between your Titan controller and also your gimbal, and then bind will be available for you to do that factory pairing. This is just in the event that you change out one of your wireless radio modules, which are interchangeable and plug and play, and you need to repair them as we do here at the factory. Next up for V1.1 is compatibility with the inertia wheels from our friends at NODO. So let's take a look at the Titan serial adapter bundle, which is used for connecting the wheels to the Titan controller and how we configure them. First thing I'm going to do is take my MotoCrane serial adapter here, which is basically a small transceiver that takes the MotoCrane CAN bus and turns it into UART for compatibility with the inertia wheels. And I got a nice quarter 20 that's captive in there. I'm just going to throw this right on top of my NODO inertia wheels, so you can see how I'm making the connections there on the backside. Now for this overview video, we're just going to connect the inertia wheels directly to the Titan controller, but within the Titan serial adapter bundle, you do get a bunch of cables for connecting the inertia wheels in a variety of ways. Look out for that spotlight video that's all about NODO inertia wheels compatibility with Titan. So currently I have my Titan wheels configured for pan, tilt, and roll, and you can see that represented right here within the wheels menu on the Titan controller. Now what happens is the moment that I unplug this first Titan wheels cable, those assignments go away. Now, one of the cool things I want you to check out is how our reactive UI updates the wheels menu here once it sees that the serial adapter and the inertia wheels are connected to Titan. And now we get the NODO logo right on my wheels. And I can just select that. And assignment to the inertia wheels is very simple. I just say I want pan to go here. I want tilt to go here. And if I had the third axis attached to the NODO inertia wheels, I could also attach roll. Now I want to make sure within the NODO inertia wheels, if I go to menu and I go to output, that I have that set signal path to aux UART here. And with all of that connected, you can see on the NODO screen that Titan has been recognized, and I should have control here of Titan with the NODO inertia wheels. So very simple setup, and again, with the Titan serial adapter, there's cables included to connect these in a number of ways. Check out our NODO inertia spotlight video that's coming soon. A more subtle but still very important change we made for the V1.1 firmware update are the changes to the user interface itself. So for instance, we now have a satellite counter at the top of the header where you can see how many satellites you currently have for GPS satellite latching. We also have a wireless signal strength indicator so that when you are operating wirelessly, you can see what the wireless signal strength looks like. We also have an icon to see if follow mode is turned on or off. So you can see if I go to control and I have follow mode turned on, you're going to see that icon update to show me that from anywhere within the user interface. With follow mode turned on, I can show you some of the features of the new reactive user interface, which is designed to give information to users or operators for why two features maybe can't coexist. So with follow mode on, I'm going to go to tuning, and I'm going to try to turn gyro stabilization off. And it tells me invalid action. At least one axis has follow mode on. And the reason is because follow mode requires gyro stabilization to be enabled. So turning it off would also turn off follow mode. So the new reactive UI makes it intuitive to learn how the system is functioning and what features can't coexist or can't be operated at the same time. The new Titan V1.1 firmware package is available for download directly from the MotoCrane knowledge base. If you have any questions about any of the features, functionality, or how to update your Titan, make sure you get in touch with our technical support team. We can't wait to hear from you and support you in your work with Titan. Thanks for watching.